Okay, question number 1. Suppose y varies inversely with x. Inversely means you have y times x. And y equals 5 and x equals 2. So 5 times 2. That gives me my k, which is 10. Okay, it says write the function model. So in other words, y times x equals 10, or y equals 10 over x. Either one would work. Okay. And then part B, there's a second part to this. Then write the function model if y varies directly with x. In other words, if y over x equals a constant. So that means 5 over 2 is my constant. So I can have this, y over x equals 5 over 2, or I can have y equals 5 halves x. And that's for the second one. Okay. For this one here, determine if it's the type of variation. So is it direct or indirect? Direct, you divide. Indirect, you multiply. If I look at this, I go, listen, x times y, that's 3. 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 So that means I have x times y equals the same thing, which happens to be 3 in this case. X times y equals 3 every time. That is inverse variation. X times y equals 3, or y equals 3 over x. Either one of those would be sufficient answers. Okay. Questions? Okay, suppose that y varies jointly with a and b. Y varies jointly with a and b, and inversely with t. That means I have the relationship y times t over a times b. That number is a constant number every time. Okay, that's the relationship between the variables. Plug in the ones I know. So I get 7 over 3 times 2 times 4, 7 times 4 over 3 times 2 equals what I'm looking for, y, when a is 2 and b is 4 and t is 3. 4 times 2 and 3 in the numerator. Plug in what you know on one side, plug in what you know on the other side, find the one thing you don't know. That's what this is. The whole secret to this is understanding how to set up this relationship here. Okay? And then solve. Let's see, 28 over 6 is equal to 3y over 8. Multiply both sides by 8. Or I can reduce this one first. I'll probably reduce it first just to make it a little easier to deal with, right? So let's see. 2 goes into both of them. That gives me 14 over 3 instead of 28 over 6. And then what I would do is probably cross multiply. So I get 9y is equal to 14 times 8. That's 80 plus 32 is 112. Right? Divide both sides by 9. Y equals 112 over 9, and that's not reducible. Because 112 is not divisible by 9. Because 1 plus 1 plus 2 do not add up to 9. Okay. Leave it like that. No reason to give me a decimal.
On the test, are you giving us the jointly and inversely?
It'll be just like that.
Are you going to give us the equations?
Ooh, no. Just like that. This is the same as the test with the numbers changed to protect the answers, and jointly and inversely might be swapped around with something else. But essentially, it's just like this. Okay, 8-4 multiplying and dividing rational expressions. So the first one, multiply. What I would do, you can multiply and then cross cancel, or you can cross cancel first. I would go ahead and reduce this down first, particularly numerically. Okay, I look at this and I go, okay, let's see, 3 goes into 15 5 times, and 4 over 6 they reduce. 2 goes into 4 twice, 2 goes into 6 3 times. So my numbers give me 3 over 10. Does that make sense? So I just do the numeric portions on would any fraction. And then I have A's on top, A's on the bottom. You're dividing, so subtract. 7 minus 2 is 5. Where does the a to the 5th go? In the denominator, because that's where the larger exponent is. So it's a to the 5th. And then b cubed, b to the 1st. 3 minus 1 is 2. And the b squared goes in the denominator as well. That's that. It does not ask for domain restrictions, so I don't need to worry about it. But if it did, my domain restriction says that a and b cannot be 0. Okay, but it doesn't ask for any domain restrictions on that particular problem, but if it did, that would be it. The next one does ask for domain restrictions. And my domain restrictions come from my denominator here, both here and in the final answer, but the final answer is not going to be any big deal because I'm just reducing this one. So I need to factor it. My denominator is x minus 3, x plus 3. My numerator is probably going to be x minus 3 or x plus 3 is one of them. Okay. So I got to figure that one out. -6, -5, -6, and +1. Divide by 2. And this gives me -3 here. So my factors are x minus 3, what do you know? And 2x plus 1. Yes? Two numbers that multiply to give me the top, that add to give me the bottom. Okay. And so from here, my domain restrictions, x can't be plus or minus 3. And then I can reduce. X minus 3's cancel. And I get 2x plus 1 over x plus 3. My domain restrictions, once again, come from the original equation and the final answer both. But everything in the original covers everything in the final answer, so I'm good. Questions? Okay. Divide and state domain restrictions. So first thing I'm going to do is I'm going to go ahead and factor this one out. Oh my Lord, let's see, let's see, 2x squared minus 5x minus 3. 2x squared minus 5x minus 3. Ooh, I know what that one is already. 2x plus 1, x minus 3. I know what that one is because it was on the previous problem. I need to factor my denominator here, 2x squared minus 5x plus 2. 4, -5. Two numbers that multiply to give me 4, that add to give me -5. Positive 4 give me -5. -4, -1. And what do I need to do? I need to divide those both by 2. So I get -1/2, and this one becomes -2. So I get x minus 2, 2x minus 1. And that takes care of that. This one is x plus 3, x minus 3, which when I invert and multiply becomes my numerator, right? So I'm dividing, so I invert the second fraction. Now I want to pause here. What are my domain restrictions? Because my domain restrictions from my original problem come from this denominator here and this denominator here. So I have can't be 2, can't be 1/2, can't be plus and minus 3. So right now, x can't be 2, 1/2, plus and minus 3. I might need to add something depending upon my final answer. I won't know until I'm done. Okay, got to factor that one out. -4, -3, -4, and +1. Divide both those by 2. So I get x minus 2, 2x plus 1. And then I do any canceling I can do. Ooh, 2x plus 1. There you go. Is there anything else I can cancel? No. So my answer is x minus 2 was what? -3, and that's -3. No, yeah. X minus 2 and x minus 2, those are both in the denominator. They have to be one on each one. So I have in my numerator x minus 3 squared times x plus 3. My denominator is x minus 2 squared times 2x minus 1. And if you wrote x minus 3 times x minus 3 and x minus 2 times x minus 2 instead of squaring them, I'm okay with that. Do not FOIL them out. Please, do not FOIL them out. Makes my life harder. Because I'll have to check to see if you FOIL them out correctly. If you have this and multiply things out incorrectly, you will lose points. One of the reasons you don't want to FOIL these things out if you don't need to is to not lose points. Because you don't want to do that. My domain restrictions do not change. I already have 2 and 1/2 listed, so my domain restrictions don't change. Questions? Okay. Ooh. Which problems require the use of a common denominator to simplify? So when you are doing fractions, what operations for fractions require common denominators? Addition and subtraction. It is irrelevant what kind of fractions you have. You just need to know addition and subtraction require common denominators. So A and F require common denominators. More than one answer. It's entirely possible. Okay. Yeah, it doesn't matter the type of fraction. You just have to know, hey, if I'm adding or subtracting, I need a common denominator. Okay. Okay, add, which means I need a common denominator. First step, factor. X plus 7, x minus 2. What do I have in the first fraction that I do not have in the second fraction? X minus 2. So multiply x minus 2, x minus 2. So I have, and I don't have anything in the second that's not in the first already, so that's already covered. So I have 2x over x plus 7, x minus 2, plus 3x minus 6 over x plus 7, x minus 2. And the one thing I love about adding and subtracting fractions is once you get the common denominator, you already know half of your answer. X plus 7, x minus 2. And in my numerator, it's addition. Add things up. 2x plus 3x, 5x minus 6. This does not ask for domain restrictions, so I'm not going to worry about it, but my domain restrictions would be 2 and -7. Always look, can I factor and simplify? I can't, so I am done. But you do want to check, can I factor? Once I combine things up, can I factor the numerator and cancel with anything in the denominator? I cannot. Question number 9, subtraction. I need to get a common denominator. Okay. This one's also kind of nice. Is there anything in this denominator, 4xy, that is not taken care of in 12x squared y cubed? No. The 4 is covered by the 12, right? Because 4 goes into 12. And the powers on both of these variables are higher than the powers on here. So once again, the first one does not change. My second fraction, however, does. What do I multiply 4 by to get 12? 3. So I have to multiply by 3. What do I multiply x by to get x squared? X. I have to multiply by 3x. What do I multiply y to get y cubed? Y squared. So I have to multiply by y squared. So that's minus 3xy squared over 12x squared y cubed. Once again, the one thing I do like about it, adding and subtracting fractions, is my denominator is already decided for me, and my numerator just combine up like terms. In which case, there are none. But you just put it all together in the numerator. Okay. Questions? Okay, simplify the complex fraction. Invert and multiply. So you need to factor. So I'm going to take the top fraction, x plus 5, factor the denominator, x minus 4, x plus 3. Take the second one and invert it, x minus 4, x minus 3. Cross cancel anything I can cancel. My x minus 4's cancel. And I get x plus 5 over x minus 3, x plus 3. That's it. Key to this is being able to factor. I'm teaching my Algebra 1 students factoring right now. And I'm telling them every day, you need to understand how to do this, because if you don't understand to do this, you're going to be screwed later. Do they listen to me? No. So I tell them. Okay. You have a question? You have a question?
On the second part of that problem, for the answer, it doesn't matter in the order of the x.
No. As long as you get them both in there, it doesn't matter. No. Because multiplication is commutative. 2 times 3, 3 times 2 doesn't matter, right? Okay. Ooh, this is a simple one, relatively speaking. You need to get rid of your denominators. You multiply through by the common denominator. In this case, my common denominator is 7x. Because I have to have the x covered, and I have to have the 7x covered. 7x takes care of both of them. So I multiply everything times 7x. Okay. My x's cancel. 3 times 7 is 21. Plus my 7x's cancel. So I get plus 5 equals. And 4 times 7x, 28x. So 21 plus 5, 26 equals 28x. Divide by 28. X equals 13 14ths, because you always reduce. So you get a fraction as your final answer, but it's not like you're adding or subtracting them, right? First step, get rid of the fractions. Okay, solve and check for domain restrictions. Cannot be solutions if there are any restrictions. In other words, look for extraneous solutions. Okay. Now, I took the problem. That's how it is printed on your paper. I wrote it down here, made it a little bit bigger to make it a little easier to work with. Yes.
On the last one,
Yes.
when you multiply it by 7x, why doesn't it work for x?
Because the x's cancel.
Okay.
That's why. Because that's what I'm trying to do is get rid of the x's. The x's cancel. Okay, so I have here a proportion. Cross multiply. If I have a proportion, I'm not worrying about anything else. I'm just going to cross multiply. So I have x plus 7 times x plus 4 equals x minus 5 times x minus 3. That's what you get, cross multiply. To solve, I do need the FOIL. X squared plus 11x plus 28 equals x squared minus 8x plus 15. And looky, I have an x squared on each side. They just cancel each other out. Because it's just 1x squared on each side. It's not like x squared and 3x squared, right? It's 1x squared on each side, same thing, it cancels out. All your x's on one side, all your numbers on the other. Add 8x, because I always like positives. Minus 28, minus 28. So 8 plus 11, that's 19x equals 15 plus negative 28, let's see, 13, yeah. Negative 13. Divide by 19. X equals negative 13 19ths. Is that going to give me 0 in either of my numbers? Either denominator? No, that one's good. Bueno. Questions before moving on? Okay. Solve, check for any domain restrictions. In other words, look for any extraneous solutions. Once again, all I did was copy down here to give more room to work. I suggest on your test you do kind of the same thing because there isn't a lot of room to work on that. You want to have room to work with it. My first step is to actually factor. So I get c plus 3, c minus 3. And now multiply everything times my common denominator. My common denominator would be c plus 3, c minus 3. So I multiply everything. C plus 3, c minus 3. C plus 3, c minus 3. C plus 3, c minus 3. My c minus 3's here cancel, and I have c times c plus 3. My c plus 3's cancel. 2 times c minus 3 equals, and here everything cancels, and I get negative 12. Listen. Distribute the c. C squared plus 3c. Distribute the 2. 2c minus 6 equals negative 12. Combine up like terms. Add 12 to both sides. C squared plus 5c equals, plus 6 equals 0 because I add 12 to both sides. Two numbers multiply to give me 6 and add to give me 5. 2 and 3. C plus 2, C plus 2. C plus 3 is equal to 0. So C equals negative 2. C equals negative 3. Can C be negative 2? It can be negative 2. That's good. Can C be negative 3? No. Okay, negative 2 will be fine in my denominators. Negative 3 will not be fine in my denominators. Question?
Wouldn't that -3 be a restriction?
Yeah, that's why I can't use it, because it doesn't work. So I toss it out. The -2 will work, the -3 will not work. Give me 0, right?
I still don't understand why it can't be negative.
Because -3 is going to give me 0 in my denominator. I cannot have 0 in any denominator at any time. Good luck. Last part, performance task. Okay, read the question carefully. You are leading a group of workers that together must clear several acres of tall grass. From past experience, you know that the number of hours, H, needed to clear land varies directly, direct variation, that ought to give you a clue what you need to do, as the number of acres, and inversely as the number of workers on the job. So I have direct variation and inverse variation. I have 3 things I'm comparing. So my first one is H. So H varies directly as A. That means I have H over A, but inversely as the number of workers. So HW over A. My first variable, and then everything else is either going to be times that or divided. Directly goes in the denominator, inversely goes in the numerator. That's my relationship. Okay. Now, there is something missing in here. Is this exactly what you guys have on yours?
Yep.
Okay, yes, there is something missing in here. You know what's missing in here? Numbers. No, do you understand what I'm saying?
I think that's on the one below.
Oh, it's on the one below. Sorry. My bad. This goes here, HW over A. My bad. That's where I do the numbers. Thank you. I'm looking at them and going, wait a minute. So that's my variation. I have to set that up. Using that, solve it by using the numbers. Last time the team worked together, 8 workers, 8W, 3H, 5A. So H is 3. 3 times 8 over 5 equals how many hours? Ooh, I don't know that. Expect to take for 5 workers times 5 over 7. And you solve that problem. Okay, that's what you do. So to clean it up a little bit, 3 times 8 is 24. Thank you. 24 over 5 equals 5H over 7. You can cross multiply. Or, yeah, cross multiply. That's what I would do here. So 5 times 5H, you get 25H equals 7 times 24. 7 times what?
168.
Thank you very much. So here I'm getting ready to show off my fantastic multiplication skills in my head. And somebody beat me to it because they're using a calculator. Which is fine. You may use calculators. Divide both sides by 25. H equals 168 over 25. Which doesn't make a lot of sense, does it? 168 25th hours. What would make more sense? Dividing it out on the calculator. I will take that, or I will take the decimal answer. Either one would be okay. Because this really doesn't make sense to the problem, does it? 168 over 25 hours. Doesn't make a lot of sense, does it? 6 what? 6.72. Is that what you get? 6 hours and 18 minutes. 0.72 is not 18 minutes. But yeah. No, it won't be 18 minutes because 25 goes in there. The remainder is the remainder over 25. So if you have a remainder of 18, it would be 18 25ths of an hour, which is not 18 minutes. Does that make sense? So yeah, but I leave it like this is okay with me if you want to do that. If you want to give me the decimal, I really don't care on this. But you understand what I'm saying? Decimal answer makes more sense than this. Okay, same idea. You're in the business of producing and selling wood chips that are used as as landscaping ground cover. As part of the forecasting of revenue and production costs for your business, it's important that you understand the relationship between the volume of wood in a tree, the height of the tree, and the girth, distance around the trunk of the tree. Yeah, how many wood chips can you get out of a particular tree? It's important to know how much you're getting out of a tree, right? If you're selling it as ground cover, you have to know how much you're going to get out of a tree when you cut it up. Because it's not going to be the same, because there's going to be air spaces in the wood chips that aren't there in the tree. You're adding it to it. You have to understand these things. How much am I going to get out of it? How many wood chips am I going to get out of this thing? Okay, you know that the volume of the wood in the tree varies directly as the height and inversely as the square of the girth. Okay, volume varies directly as height, volume over h, inversely as the girth. VG squared over h. Okay? And that's just know it directly, know what inversely means, and how to set it up. Okay? Take that, plug in what you know. That the volume of a small tree is 130 feet for volume. Height is 35. And the girth is 1.5 times 1.5 squared. That is important. Find the height of the tree with a volume of 600 cubic feet. 600 times girth of 2.5 squared over h. What is it that I'm holding in my hand? Calculator. What do I expect you to use on solving this problem? A calculator. Okay. So let's see, 1.5 squared. Ooh, I got to turn it on first.
It's 292.
Yeah, 0.5 squared times 130 divided by 35. Ooh. So I get 8.357 blah 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 on one side equals 3750 over h. Okay, you want to see something really cool? Easy way to solve this problem. Here you go. If I do that, what do I have? I have a proportion. Now here's the cool thing, and this is something I didn't cover with the other proportions. Proportions are really awesome because you can do lots of things with proportions. If you have a proportion, one of the things you can do is you just flip both sides over. It's still equal. So I can just flip that over. 1 over 8, point over 8 equals h over, and that's, or here's the other really cool thing, and this is one of the ones I love when I set this up, is that I can swap a couple of things and still have to be true. I can swap these, and it'll still be true. So that means that h over 1 is equal to 3750 over 8.357. And that's still true. You can swap these two, or you can swap these two, or you can flip the whole thing over. And it's still the same proportions. Everything is still equal, which is really cool when you're trying to solve. Okay. Now, if you didn't want to do that, multiply both sides by h, divide both sides by 8.357, and look what you get. You get the same thing. Okay. And you divide by 8.357, and you get 448.725. To the nearest foot. Yeah. So this would be to the nearest foot, 449 feet to the nearest foot. Notice you don't round off until your final answer, though. If you round off early, you're going to have problems and you'll be wrong. Okay, that's one of the things I always preach. Get round off error. If you round off too soon, you get round off error. Okay.